Hey everyone, welcome back to HackProKP, where we dive into the world of hacking and cybersecurity. Today we are going to explore the UDP checksum. We will break down what it is, why it is important, and walk through a step-by-step example. So let's get started. UDP or User Datagram Protocol is one of the core protocols of the Internet Protocol Suite. It's used for time-sensitive transmission like video streaming, like you're doing right now. You're watching a YouTube video or playing video games. So it is used for video streaming and while playing games. But unlike TCP, UDP doesn't guarantee delivery, order, or error checking. So it doesn't really guarantee the delivery. It doesn't guarantee orderly delivery of the packets and error checking, except for one thing, the checksum. The checksum is a form of error detection that ensures the integrity of data being sent. If the data is altered in transmit, the checksum will not match, indicating an error. So a checksum is going to make sure that we have integrity. Integrity of what? Our data. The data that we are sending. Let's break down how the checksum is calculated. The process involves binary addition and ones complement calculation. So let us start with binary addition. We are going to start with the basics of binary addition. So let us consider that we want to add 0 plus 0. Now these are binary numbers. So if we add 0 plus 0, what do we get? We get 0. Now if we add 1 plus 0, what we will get? We will get a 1. Now this doesn't really matter if we flip and we add 0 plus 1, we are still going to get 1 only. Now what happens when we add 1 plus 1? So let's do that. When we add 1 plus 1, we get a 0 and a carry of 1. So what is the final output? We get 1 1. So this is the output. Now let us understand and one more important step in binary addition. Let us consider this. We are adding 3 binary ones. So what will be the output? Let's break this down. So we know that if we add 1 plus 1, we will get 1 0. So we'll get a small carry and we will get a 0. So what is 0 plus 1? We already know that it is 1. So we get the output as 1 1. Hopefully you were able to understand this process. Now let's talk about the easy part, calculating the ones complement. Now calculating the ones complement is pretty easy. So let us consider you have a 1. So what will be the ones complement of flipping the 0? What we will get? We will get a 0. And what if we have a 0? We will get a 1. So actually what will happen? Let us consider a small example. We have 1011 as our binary number. What if we want to flip this number? What will happen? 1 will change to 0, 0 will change to 1, 1 will change to 0, and so on. So this is going to be the ones complement of this particular number. Hopefully you were able to understand this. Now let us talk about how the UDP checksum is actually calculated. So UDP checksum is the addition of UDP header plus UDP data and pseudo header of IP protocol. So we know that the UDP checksum is actually the addition of UDP header plus UDP data and pseudo header of IP protocol. Now this IP is network layers internet protocol. Now let us understand what this pseudo means. So pseudo actually means some part. So some part of the IP protocol we are actually using to calculate the checksum. We don't really need to understand what some part we are actually using right now. because we are going to discuss about this in the network layer protocol. Steps for calculating the UDP checksum. So there are majorly two steps that we need to make sure we remember. Step 1 is binary addition. So actually, we're going to add three 16-bit digits. And what happens if we get a carry? That carry is actually wrapped around. What does that mean? We add that carry to the least significant bit, and whatever we get the output, that output will be the output for step number 1. Now what happens in step number 2? In step number 2, we just find the ones complement. Now we know that this ones complement is just converting or flipping the bits. So 1 will convert into 0 and 0 will convert into 1. So whatever output we are going to get from step number 1, we are going to do the ones complement for that. And after processing, we are going to get the final checksum. Okay, now let us start with example number 1. So you can see three 16-bit digits we have. So what we are going to do, we are going to find the binary addition for this. This is going to be step number 1. So I want you all to pause this video and calculate this by on your own and then confirm the output with my solution. So we can see that this is the output that we get after adding these three digits. Now there was no carry, so this is going to be the final output. So this is going to be the output for step number 1. Okay, now let's start with step number 2, that is flipping with the bits. So what we are going to do, we are going to flip these bits. And what will be the final output for step number 2? Step number 2, we will get the output as this. So we have simply flipped the bit. Now this is the output. And this is going to be the final output. So this is the checksum that we are going to send to the receiver. Okay, now let us consider that the data that we were sending and the checksum is received by the receiver. So what is going to happen on the receiver side? The data that has been received is going to be added with the checksum. So we are going to add all of these four 16-bit numbers, and if we get all ones as the output, that we will get in this case. So the output, if we get as all ones, then the data is verified. And if there is any kind of errors, like for example, if there is a 0, we don't really get all ones, then we know that this is not the correct data, or error has been occurred while transmitting the data, and all the data is going to be rejected. So one small important thing that I wanted to add is that UDP checksum is actually not compulsory when we are using IPv4 addresses. And if you are using IPv6 addresses, then UDP checksum is compulsory. So there's a possibility that you don't send UDP checksum when you're using IPv4 IP addresses. Okay, so now let us take another example to understand this properly. If you will see in this one, we're getting an extra bit. We are getting a carry. So what happens in this case? Actually, what we are going to do, we are just going to add this number again. What we will get after adding? So we will get the output like this. So this is going to be the output that we are going to get after addition. So after this step, all the things are the same. Okay, so let us start with step number 2. So we are going to flip all the bits, and this is the output that we are going to get. So this is going to be the final checksum that we are going to send alongside with the data to the receiver. Okay, so on the receiver side, the receiver is going to calculate or add all the data that he got. So he's going to add the data with the checksum, and if he gets all ones, that means that the integer of the data is maintained. So after he do the addition, he gets the output like this. So he's getting one more carry in the output part. So what happens? Again, similar to what we did before, we are going to add this carry to the least significant bit, and we're going to do the addition part again. Okay, so after the receiver does the binary addition again, he will get all ones as the output. So this means that the data integrity is maintained and the data is verified. So there you have it. That's how the UDP checksum works. Hopefully you were able to understand the UDP checksum in detail. Thank you for watching this video.